Thank you for joining this presentation. My paper titled Public Perception of ChatGPT and Transfer Learning for Tweet Synonym Analysis using Wolfram Mathematica. My name is Yan Kang Su. I'm currently studying in the University of Illinois Urbana-Champaign as an undergraduate freshman. And this paper was written during one of my high school academic programs. So in recent years, ChatGPT and the similar AI tools have quickly gained widespread use among other people. Almost everyone has the experience of using such AI tools in their daily life. And therefore, the evaluating the public opinion is very crucial. It highlights specific strengths and weaknesses from the user's perspective. So in this paper, we aim to fill this knowledge gap by using the natural language processing, the NLP, to analyze tweets about ChatGPT. And specifically, I used um, Wolfram Mathematica, and there is some built-in classifiers, built-in machine learning models that already exist. So we want to see how effective these models are, and if they're not effective enough, I'm trying to build my own machine learning model. So um, starting from so these are I propose several research objectives and questions in my paper. Oh, and by the way, this one is written in a Mathematica notebook. So it's very beneficial to use because it can combine the text, the code programming, and also different charts that can help the visualization. So to begin with, the data set I use is from the Kaggle website. It's called 500K ChatGPT related tweets from January to March 2023. So this is basically a CSV file. As you can see, I use the import keyword to import this CSV file and save it to the data set. And before we can continue with our model training, we have to do the pre-processing for the data, because we know that on Twitter or the similar social media are a very good way of evaluating people's opinion, because people tend to express their real idea on this social media platforms. But that also causes a problem, is that the language that people use is often very informal, so which causes them to be sometimes confusing, um, misleading, or not helpful to our machine learning. So we have to do some processing. First of all, these are some examples of the data pre-processing. There are some common abbreviations like won't, can't, or nt, not. They were transformed into the full forms like will not, cannot, and not. Besides, we eliminate URL because the links are often less helpful for us to evaluate the sentiment that are expressed through those tweets. There are some other examples of the data processing, like the elongated word correction, numerical value removal. There are different ways, but their goal is similar: to make the data set more accurate, to help the machine learning training. And after that, we sorted the data set. So before we can proceed with our data model training, we want to see how these data sets, these tweets actually look like. Make sure we correctly imported those data. So here are the data understanding. Here are some examples. Like we include the date, the ID, which is like the user ID, and the content. As you can see, this is actually the content is unprocessed because it includes a username, emojis, and the URL. So these are less helpful, or we consider them to be useless. So we will later eliminate these parts. Before the model training, I also did some basic statistical analysis, like the first uh, quartile, the minimum, median, third quartile, mean, and max. So they can all be easily achieved through the built-in math functions in the Wolfram Mathematica. And here is the tweets exploration. One of the advantage of using the Wolfram Mathematica notebook is that it makes the visualization of data very easy. So I created the histogram based on the date. As we can see, the histogram in the beginning of the February and the mid-March are the highest. We can see two peaks in here, and we will find later why there are two peaks of the tweets that discuss about ChatGPT in this two time. Similarly, the previous one is based on each day. As you can see, each histogram, each bar is thinner, and this one is based on week, like each week. About the topic classification and modeling. So first of all, we try to use the Wolfram Mathematica built-in classifier that this classifier already exists, and so we don't need to import them. This histogram shows the prevalence of different topics that are discussed in the tweets of our dataset. We can see the top few topics are technology, video games, social media, career and money, and politics, like this. So in our topic modeling, we employed the LDA method. It's on unsupervised learning. LDA helps categorize a document by clustering. And in this case, we want to categorize them by the topics. So as you can see, the color of this part of code is kind of different because this is actually from the external editor, which is Python. Yes. So in the Wolfram Mathematica notebook, the users can easily import the external language like Python, C++, Java, and so on. So this makes the machine learning process much more easier. So this code and with the yellow background, they're actually written in Python. So here is a visualization of the distance map between different topics. On the right side of this picture, we can see the keywords that have been discussed the most are like the ChatGPT, HTTP, and ChatGPT AI. So this is actually very reasonable because this one is about ChatGPT. So the keywords of this show up most of the time. And also, I created a word cloud of tweets like this one. It's actually a logo of the Twitter. Previously, it's not called X, but this one is just like a bird. So the bigger the word is, that means the more prevalent the word is. For example, we can see the biggest word here is a ChatGPT. That means the number of the word ChatGPT appears most in all the data set. This is one of the interesting visualization that we can easily done in the notebook. So these are also the similar another way of expressing the previous keywords like technology, video game. We put in a table, and then here comes to the most important part: the tweet sentiment analysis based on the transfer learning. So we proposed the research questions like how effective is a built-in classifier, and how can the pre-trained models in Wolfram neural net repository be leveraged for transfer learning to perform the sentiment analysis on the tweets. So also we start with a data source. So in this section, we use the called sentiment 140 dataset. So it has been extensively applied in the related Twitter sentiment classification literatures. So also we want to take a look at how does tweets look like. We can see that this language is actually very informal. So of course, we need to pre-process this tweets in order for the content um, uh, to be more accurate. But before we start to train my own model, I set a baseline. It's called built-in classifier because later we will want to compare how effective our model is comparing with the built-in classifier was the Wolfram Mathematica. So um, in this section, I tried different models, built-in models. So the first model we used is called Markov. There are a lot of models we can use. So as you can see, the accuracy when the training examples is very big, the accuracy will approach around 0.73, like 73%. It's a acceptable result, but it's not so satisfactory. So we definitely want to improve this model. We want to try some other models to find the most accurate uh, language model that can predict the sentiment of the tweets. So, and later, I used the GLOF plus LSTM model. So this one from the chart, from this graph, we can see the accuracy is much more better. It's much better. So the accuracy is approaching more than 80%. That's a pretty good result, and it's much better than the previous Markov building model. This shows how the model works, like the visualization of how the data is processed, how the data were used to train the model, and how the output is generated. Aside from that, I also tried to use ConceptNet plus LSTM. It's just another way of the machine learning model. So let's look at the accuracy graph again. So this one is even better. It's approaching around 85% accuracy. So this one, we can see the ConceptNet plus LSTM is the best model so far. The fine-tuning BERT is another model we used. This one approaches the 80% accuracy, and it keeps on the line of 80%. It does increase as we increase the size of the data. So this one is a fine-tuning Elmo. So here is a sentiment analysis of tweets on the ChatGPT topics. So first, we try to classify the sentiment. So we know sentiment can be basically divided into three categories: positive, negative, and neutral. So with the built-in classifier, we got this result that can be visualized through this pie chart. So surprisingly, most of these tweets are neutral sentiment, and the rest of them are some positive, some negative. But after we try to classify the sentiments, I suspect that there must be something wrong with this because we know that people, when they go on the Twitter or the social media, they always express most of the time they express their true idea. So they have to have opinion instead of being neutral. So with that being said, I'm motivated to create my own model that can predict the sentiment more accurately. That is a GLOF plus LSTM deep learning model. So this section utilizes a deep neural network model. It has been trained and exported, as discussed in the previous section, to analyze the sentiment of the top 10,000 tweets with the most likes from the dataset. So let's see how the result goes. So So this pie chart is completely different from the pie chart generated by the built-in classifier. Most of the tweets, I would say around 60% of the tweets are positive, and the rest of them, most of them are negative. And they're all also there's only a small portion, about I would say 30% of the tweets are the neutral sentiment. I would say this is much more reasonable because usually people go on Twitter, they express their opinions. So there must be opinion, whether positive or negative. So this chart is pretty much the same thing as a pie chart. It's just visualized through different the graphs. So finally, we have the result and analysis. So in this research, we introduced and examined four different transfer learning methods. So they're all within the realm of deep learning, transfer learning as the essential paradigm. So to comprehensively access this for methodologies, a series of experiments were conducted because we want to use some index, so some mathematical index to quantitatively see how accurate each model is. So we introduced this four index: the ACC, uh, precise, recall, and F1 scores. So each column is a model that we previously used. We can see from the precise row, the Glove plus LSTM column has the greatest value for all this for index than any other models. So far we can conclude that the Glove plus LSTM model is the best model so far that we have trained to analyze the sentiment of tweets and to do the classification of the topics. So within the study, we harness the capability of the NLP to to see how people on Twitter view ChatGPT, what their opinion is, what their sentiments toward it, whether positive or negative. Um, so in conclusion, we also did the topic classification, modeling, and tweet system analysis using the Wolfram Mathematica computational platform. Secondly, the research led to the development and subsequent validation of the topic classification modeling framework, specifically related to the ChatGPT. So I'm currently studying as a freshman in the UIUC, and this topic I think it's still a very good topic of the research, and I will continue delve deeper into the NLP analysis. So I will definitely improve this research because there are, of course, some uh, disadvantage, something that still need to be improved. So this is basically all I want to talk in this presentation.